Hi, Chris Kuzmal here. We're now continuing with relational logical sentences, and we're talking now about the syntax of quantifiers. To create a syntactically legal logical sentence with quantifiers, we begin by writing a syntactically legal relational logical sentence that has no variables. The example we see here is there's not a cat that is a ball. Ball, excuse me, I misspoke. Ball one is not a cat, or leopard is a ball. And we're going to replace one of the object constants with a variable that has not been used. In our example, since x has not been used, we can, without a loss of generality, replace ball one with x. Then if we place parentheses around that sentence and place either a for all x or there exists x, a universally quantified x, or a existentially quantified x, in other words, then what we have now is a syntactically correct, syntactically legal relational logical sentence. So let's look at a few examples to check whether or not we understand syntax. For example, if we say, is cat leopard Dasha, that is syntactically correct because the arity of is cat is 2, is cat is a relation, leopard and Dasha are each object constants. The parentheses and the comma are where they belong. If we say kicks Dasha ball one, that also oh, I'm so sorry. Is cat is not a legal logical sentence. It seems like it, but it's not this sentence is not correct because although it makes intuitive sense that both leopard and Dasha are cats, is cat only has an arity of 1, and so it cannot take 2 arguments, even though it really seems correct. Here we're okay. Dasha kicks ball 1, no problem. Dasha and ball 1 are both object constants, and kicks has an arity of 2. Notice that I'm not paying attention to whether or not it makes sense for Dasha to kick ball 1. We're just saying that since they're both object constants and kicks has an arity of 2, we're okay. So, for example, if I say kicks Dasha Dasha, that tends not to make a lot of sense, but it's still syntactically correct. Now, for example, if I do a quantification of W, if there exists a W, and then I do W of Dasha, I'm using W as a relation, but W is only something that would replace or could be replaced by a object constant, not a relational constant. And so in this case, we're using W as a relational constant, and that's, or potentially arguably conceptually in place of a relational constant or as a relation. And that's not syntactically correct in relational logic, even though it might make perfect sense. Intuitively, if we have any relation that applies to a thing, that implies that relation applies to the thing. Sure, we believe that, but it's just not syntactically correct, okay? Now here we say leopard is not a cat. Semantically, it doesn't make sense. We all know that leopard is a cat, so this statement very likely is always false, but syntactically, it is also correct because is cat takes 1 argument, it is unary, and the negation operator certainly can be put in front of any logical sentence. If we say kicks Dasha of Z, that's fine, even though Z is not quantified because Z can be what we call a free variable. We'll talk about that in a little bit. If we say there exists an X such that kicks Dasha X, that looks good to me. We'll check in a second, but I'm pretty sure, yeah, kicks is a binary relation, and X is functioning as if it were an object. So yeah, that looks good to me. And also, if we don't use the variable y in this example, the variable in the logical sentence, that doesn't remove its syntactic meaning. It makes it kind of annoying in terms of what does this mean, but it's still syntactically correct. And so, in particular, now we identify the cases that fail. Is cat for leopard and Dasha, and there exists W such that W of Dasha implies W of Dasha. Every other logical sentence here is syntactically legal.